Hello class, this is Mr. Sutton, and today we are going to be talking about trapezoids and kites. So some definitions for your notes. Trapezoid is a quadrilateral with exactly one pair of parallel sides. So would look something like this, right? An isosceles trapezoid is a trapezoid in which the non-parallel sides are congruent and the base angles are congruent. So the isosceles trapezoid is your trapezoid, but we also have these two sides are congruent. So we have these opposite sides parallel, and then the other sides are congruent, and then the base angles are congruent. So that means this angle is congruent to this angle. It also means this angle here is congruent to this angle here. And then the mid segment of a trapezoid is a segment that connects the midpoints of the legs. So here, let me draw another trapezoid. So we got parallel lines, and then let's say our midpoints are here and here. The mid segment connects the two. So that means that this is congruent to this, and this is congruent to this. Some properties of the mid segment. The mid segment is parallel to the other bases, so I can draw another arrow here. All three of these lines are parallel. And the length of the mid segment is the average of the two bases. So if we call this B1 and this B2, and then call the mid segment BM for M for mid segment, your formula to find the mid segment is B1 plus B2 divided by 2 equals BM, or the mid segment. All right. So make sure you have those all in your notes. Pause the video if you need to make sure you get all this down, including some picture examples. And then we'll look at some examples here. So example 1, we are going to find the missing angle measures here. This is an isosceles trapezoid. We have parallel lines and we have two congruent legs here. So what that means is that the base angles are congruent. So these two angles are congruent, and then this angle is congruent to this angle. So that means if this is 115 degrees, this has to be 115 degrees as well. So we already have 2 out of the 4 angles we need, or 1 out of the 3 missing angles. The other angles we could find, because we have transversal angle pairs. We actually have, because we have parallel lines here, that's parallel to this. And then we have this transversal line here. Right? So we have 2 parallel lines, and so TR and PA are parallel lines, and TP is a transversal line. We have same side interior angles. RTP and TPA are same side interior angles, so that means they are supplementary. So these two angles should add up to 180, so I can figure out what this angle is if I take 180 and subtract 115. So that is 180 minus 115. That is 65 degrees. And if this angle is 65 degrees, this angle is 65 degrees as well, because they are congruent. And all of these should add up to 360 because it is a quadrilateral. So that's a way you can check, make sure your answers make sense. Another way you could also find missing angle measures for these trapezoids. Example 2, we have some algebra mixed in here, some unknown algebraic expressions. So here we have an isosceles trapezoid. We already have the legs marked congruent and the base angles marked congruent. So we can find x, since these two sides are congruent. That means we can set them equal to each other. So we'll say 11 equals x minus 4. And then, or x minus 4 equals 11, and we can solve for x by adding 4 on both sides. And we get 15 equals x, or x equals 15. right? And y, we can solve for, because these two angles would not be congruent. Notice they have different markings here, meaning that they are not congruent, or not necessarily congruent, but they are supplementary, because this angle right here is congruent to this angle here. So that means this has to be y degrees as well. And these would be same side interior angles, right? So once again, we have consecutive, or we have supplementary angles here. So these we would not set equal to each other. We would add them up. And since they're supplementary, the sum should equal 180 degrees. So this is how we'd set it up. We can combine like terms. 4y plus y is 5y. Add 20 on both sides. Divide by 5 on both sides. You get y equals 40. So that would be your solution for x and y. And then if it's asking for a specific angle measure, you'd have to plug that back in. But for this one, we're just finding x and y. Here we have a mid-segment. So we know it's a mid-segment because it is connecting the midpoints of the two legs. L is a midpoint of F and K because we know that FL is congruent to LK. We have these markings here. So that means L has to be a midpoint. And H is a midpoint of GJ. We know that because GH is congruent to HJ. We have these markings here. So this is a mid-segment. So that means that the length of the mid-segment is equal to the average of the two bases. So even though we don't know what this base is, since we do know what the mid-segment is, we can set up a equation. Remember what I said before. If I say this is B1, this is B2, and this is BM, our formula would be B1 plus B2 divided by 2 equals BM, and then we can just plug in our things. So we got 23.6 for B1, X for B2, divided by 2 equals 18.6. And now we have something that we can solve for X. First, to solve for X, we multiply by 2 on both sides. So the 2's over here cancel. We got 18.6 times 2 is 37.2. And then subtract 23.6 from both sides. And you get 13.6. Right, so that would be the length of this base on the top. Okay. Here's another example with mid-segment formula. So this time, assume that this is a trapezoid and that we're given that this is a mid-segment here. So our setup for this one would be 2x plus 17 plus 23. So you have our two bases, 2x plus 17 and 23 added together, divided by 2 equals the mid-segment, which is 29. We have some combining like terms that we can do. 17 plus 23 is 40. Now, we have a choice here. We can multiply by 2 on both sides, or we could actually simplify this because both terms in the numerator can be divided by 2 nicely. So I'm going to go ahead and do that. You can separate this into 2 fractions and see that 2x divided by 2 is just x. 40 divided by 2 is 20. and then subtract 20 on both sides, and you get x equals 9. So that would be your x value, and then if we were to want to find this side length, we would just have to plug that back in for x. Okay. Kite definitions. So, new section on your notes. Write down these definitions for kite. Pause the video if you need to. Kite is a quadrilateral with two pairs of consecutive congruent sides. Opposite sides are not congruent. If you know what a kite looks like in real life, like the kind that you fly around, it should help you visualize this. So these two consecutive sides are congruent. These two consecutive sides are congruent. Opposite sides are not congruent. So this side is not congruent to that side. That is why they have different markings. So that's what it looks like. Properties of a kite. The diagonals are perpendicular. So let me draw a bigger one here. So if I were to draw in some diagonals from the opposite corners, they meet at a right angle. And then also another property is that one pair of opposite angles are congruent, and that would be this angle and this angle. These are congruent to each other. The angles that are between the non-congruent sides are always going to be congruent to each other. This angle right here is not congruent to this angle. These two angles are distinct. These two angles are congruent. Okay. All right, let's look at some examples with kites here. This first one, these are the angles that I said are going to be congruent to each other. So we can actually use the same variable to identify them. You can pick either x or y. I'm going to go with x. So I'm going to rename this angle x also. The reason why I'm going to do that is because I know that they're the same measure, so that when I set up my equation, it's something I can solve for because I know all the angles should add up to 360. And since these are the same, I can use the same variable and combine like terms. If I were to set it up like this isn't something I can solve because it has two different variables in it. But since I know that they're the same, I can use the same variable, and then I can solve it because there's only one variable in it. So combine like terms, x plus x is 2x. 95 plus 60 is 155. Subtract 155 from both sides, and you get 205. And then divide by 2 on both sides, and you get x is 102.5. So that means that both of these angles are 102.5 degrees. Here we want to use the fact that the perpendiculars create right angles. So we have these small triangles that we can find missing angles for. Is here we have a triangle that has degrees. This KSE triangle here has angle measures of 40, and then we know this is 90, so we can figure out the third angle measure there because triangles, the interior angles add up to 180 degrees. So if we take 180 degrees, subtract 90, and then subtract 40, we know that this angle here has to be 50 degrees. So all of these need to add up to 180. And we can do the same thing over here. This triangle KSL, I guess is what that is. These three angles should add up to 180 degrees. So 180 minus 90 minus 65 leaves me with 25. So this angle here has to be 25 degrees. And then this triangle here, KEL, the big triangle, has to be congruent to TEL by side, 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 right? We have this side is congruent to this side, ET is congruent to EK, and EL is congruent to EL by reflexive property. So all of these angles up here should match all of these angles down here, because these two triangles, ETL and EKL, are congruent by side, side, side. Okay, let's look at one with some algebraic expressions. We know that these opposite angles are congruent, but these opposite angles are not the other opposite angles. So to find y, we will need to add all the angles and set it equal to 360 degrees. So combining like terms, we have 112 plus 112 plus 1 is 225. And then y plus 2y is 3y. So subtract 225 on both sides. That's a terrible y. And you get 135. Divide that by 3. Divide both sides by 3, and we get y equals 45. So this angle here is 45 degrees. To find this angle, we'll have to plug that in. So we'll have 45 times 2 plus 1 is 91 degrees. Okay. And I just have one more example here, and this one's kind of a trickier one. So ABCD is a kite. So we got AC is perpendicular to DB. This symbol here means perpendicular, meaning they form a right angle. And DE is congruent to EB. So that's these two sections here. Calculate the length of AC. We want to find the length of this whole thing. So here, when we're dealing with side lengths for kites, we are most likely going to be using Pythagorean theorem, because we have all these right triangles that we have created. So the best way to find the side lengths is to use Pythagorean theorem. First thing we want to do, if we're trying to find AC, again, that's this section here, we're going to need to find CE on its own and EA on its own. And the reason for that, and then we'll add them together, the reason for that is because even though it might look like ACD, this triangle here, is a right triangle, it is not. This is not a right angle. So we cannot, I think your first inclination might be, I'll use this length and this length to find this length using Pythagorean theorem. But that does not work because this is not a right triangle. Our right triangles are only the 4 smaller triangles. So those are the only ones we can use Pythagorean theorem on. So what we'll have to do is find this length on its own and this length on its own, and then add them together. Okay, but we can do that. So we know this whole thing is 10, so that means that this is 5 and this is 5. So we can find CE using this triangle here. This is a right triangle. 6 is the hypotenuse. CD is the hypotenuse. So we got, and then this would be our unknown side. So I'll call it x. So we got x squared plus 5 squared equals 6 squared. 5 squared is 25. 6 squared is 36. 36 minus 25 is 11. Oops. Square root that. And we'll just say square root of 11. That does not simplify any further, so I'll leave it like that for now. It does say round to the nearest tenth of a centimeter, but I'm going to save that for the end. So we'll call this square root of 11. And here, from E to A, we'll call that Y. For now, we can use this triangle, AED, to find that. That is a right triangle, and we know the hypotenuse is 9, and this leg is 5. So we can use Pythagorean theorem. Y squared plus 5 squared equals 9 squared. 5 squared is 25. 9 squared is 81. Subtract 25 on both sides. Your y squared equals 56. Square root both sides. And square root of 56 simplifies to 2 root 14. So y, in this case, equals 2 root 14. But it doesn't really matter if you simplify the radical or not, because we're going to end up rounding to the nearest tenth of a centimeter anyways. So now we want to add these two radicals together, and this I recommend you doing in your calculator. Square root of 11 plus 2 root 14, or square root of 11 plus square root of 56. You should be able to type it in just like that. And that's the best way to do it. Type in that full thing and see what your calculator spits out. You might have to convert it to a decimal depending on what calculator you're using. But if you need to, there's usually a button that has arrows pointing in both directions that will convert it to a decimal for you. If you're not sure how to do that, talk to your teacher, and you should get 10.8 centimeters. It's really 10.7999396, but we want to round to the nearest tenth. So that's how you do that problem. Thank you for watching, and have a good day.